Okay, number 6, guys. What I did here was I took cos x out as a common factor at the top and the bottom, which is also, I think I mentioned it yesterday that you could do that. And now because you have one term at the top and one term at the bottom, you can actually cancel those cos x's out. And you're just left with what you had in your brackets. So 1 minus cos squared x is equal to sine squared x, right? And 1 minus sine squared x is equal to cos squared x. And sine squared x over cos squared x is equal to tan squared x. Just hold on, Jasper, I'll be with you now. What I did here on the side is just when you're looking at what's given and you're thinking, okay, I have to change this to that. It is useful to remember or to just maybe write down that tan is actually sine over cos. So that's what you're working towards, all right? You actually want to get your numerator to sine squared x, and you want to get your denominator to cos squared x because that is equal to tan squared x. Yes.
So my was going to ask you cos x times sine squared. So then isn't it minus 1 times? So how do you actually get there? I got the answer, but I wasn't sure how we get the 1 minus sine squared.
When you take it out.
Yeah, we just said it was -1 times sine squared.
Which is just sine squared x. It is the same thing, yeah. Because it's one term. So you essentially, if you do this, if you have, you can also just think of it as cancelling out the cos x. If you have that, and you now divide it by cos x, you're just going to cancel those out. You see, and you're just left with negative sine squared x. But it is -1 sine squared x, but you don't have to write that 1. Because 1 times anything is just that thing.
Yeah, no, I understand. But then how did positive? How does the 1 at the front become positive?
Because we're looking at that term there. So you're saying cos x divided by cos x is 1. You're taking each term separately and dividing it by cos x. When you take it out. So that 1 comes from this first term. Cos x divided by cos x is 1, and then this divided by cos x is negative sine squared x. Yeah, remember when you're taking out a common factor, you divide each term by that common factor. So if you're starting with 2 terms, you always have to have 2 terms in the bracket again. All right, is that fine for number 6, guys? Can we look at 12? 12 is a bit more complicated. I did it on a different page here. There we go. What I did here on the side was I just reminded my class from last year how to add fractions. So I just did a numerical example there. All right, so you're starting with the left-hand side. I would start with the left because there's just more that you can do on the left. So I left my first fraction as it was, and I changed tan x to sine x over cos x. All right, guys, if you don't know what else to do, just do that. You'll get a mark for it 99% of the time. But now we see that we have 2 different fractions that we are adding together. Okay, now we went through this yesterday, but I'll just say it again. When you are adding 2 fractions together, you need to put them both over the LCD. Now the LCD in this case is going to be cos x and 1 plus sine x in brackets. That's your LCD. So you need to ask yourself, you can see I wrote it here. What must I multiply this denominator by to get it to this? If I already have 1 plus sine x, I need to multiply it by cos x. But then I must do the same thing at the top. Okay, so that is where my cos squared x came from in the next step. It's because I did cos x times cos x, which is cos squared x. Okay? If we're looking at our second fraction, my denominator currently is cos x. I want it to become the LCD because if I have the same denominator, I can put it over one fraction, right? So what must I multiply cos x by to turn it into this LCD? 1 plus sine x. Then I must do the same thing at the top. Now, you could have just written it separately. So you could have written sine x bracket 1 plus sine x in the next step if you wanted to, but I just multiplied my sine x into the bracket straight away. All right, so sine x times 1 is sine x. And what is sine x times sine x? sine squared x. Now, because they're both over the same denominator, I can write it over one denominator. Okay, so that's how I went from two separate fractions to my one fraction. So a lot of work went into actually getting this. All right, so guys, it will also be many marks for this step. You will get a mark for having the correct LCD. You will get a mark for your cos squared x, and then you'll get 1 mark for both of those terms. So for multiplying the numerators correctly as well. So that would be 4 marks already, just for getting to that point. Now, something that is difficult to see because they're not together, but do we notice what I've circled here? Cos squared x and plus sine squared x. What's that? 1. So do you see how I went from this numerator to the next step? Cos squared x plus sine squared x is 1, and we have a plus sine x. And now that's quite convenient because we have a 1 plus sine x in our denominator, all right, in brackets. So guys, you can actually cancel out your whole numerator with that bracket in your denominator. And what is then left at the top? If I've canceled the whole thing out, remember canceling out is actually dividing, right? So you actually say 1 plus sine x divided by 1 plus sine x, which is actually 1. And at the bottom, we're left with cos x. Yes. It is, but if you just do this, then that's 1. Right, so you can, yeah, you can trick your way out of that one. You can cancel it out as long as you cancel the whole numerator out, if that makes sense. Okay. Did anyone do something different for this one? I'm sure there would have been other things that you could have done. No, no takers. All right. Yeah, guys, if you didn't get that, please copy it down. We're going to practice some more difficult ones now, and then you're just going to do some more on your own. Yeah. Mm-hmm. Yeah. Yeah, that's fine. Mm-hmm. Okay, you can make heading proving more difficult identities, I suppose. Yeah, I know. I just think some people are still copying down. Okay, there we go. Proving more difficult identities. Okay, this is a fraction, so I'm going to write it over 2 lines. Okay, guys, I think it's obvious to see here that we can do more things on the left, right? The right-hand side is just sine x. So let's start by working on the left. And what is the first thing that we notice there? We have a tan, right? So let's change that to sin x over cos x straight away. And then we'll see what we can do after that. Nothing else here is actually, yeah, we can't really change anything else at this point, except for that tan. So we have 1 plus 1 over cos x, or in the denominator. Now guys, what we have here now, I'm not sure, I might have mentioned it to you before, I can't remember, but have we worked on compound fractions before? Have you heard that word, compound fraction? Yeah, yes, Jasper?
Amount is the thing at the bottom of the here.
What, no, I'm not sure what you mean.
1 minus sine. Because then it's how much it becomes. Doesn't have to be squared.
Yeah, that one only works. Now guys, this is a compound fraction because we have fractions within a fraction, if that makes sense, right? We have a fraction in our numerator, we have a fraction in our denominator. So I'm just going to say here, compound fraction when there are fractions in the numerator, in the numerator / denominator, or both. Okay, so even if you just have one fraction in the numerator, it's still called a compound fraction because you have fractions within fractions. All right, now the way of solving this, we might have done it in different topics. I can't quite remember, but what you're going to do to get rid of the smaller fractions, right? You're going to multiply the top and the bottom by the LCD of the smaller fractions. Okay, so I'm going to write that down, then I'll show you how that works. So then multiply top and bottom, or numerator and the denominator, same thing, by LCD of the, and then we not say smaller, I'm going to say the inner fractions. That's more that's more correct, I think. So guys, what are my inner fractions here? It's sine over cos and 1 over cos. So what's the LCD of those two fractions? Cos, right? They have the same denominator. Do we see that? So the LCD is going to be cos x. So that is what I'm going to do at the top. I'm going to multiply the top by cos x, and then I'm also going to multiply the bottom by cos x. Now guys, this is a trick because what I'm actually multiplying by is 1. What is cos x divided by cos x? 1. Hey, I'm deciding to multiply the top by cos x and I'm multiplying the bottom by cos x. But that actually is 1. Cos x over cos x is equal to 1. So what I'm actually doing, right, by multiplying the top and the bottom by the same thing, I'm multiplying this fraction by 1. And guys, if you multiply something by 1, does that change the value of that thing? Right? If you just think, what's 5 times 1? It's still 5, right? But we're multiplying by 1 in a clever way, all right? We're using a trick. Instead of just multiplying by 1, which isn't going to help us because we're going to get the same thing, I'm multiplying by 1 in such a way that it will actually cancel out these denominators of the inner fractions. Okay, that's why we're allowed to just do that, because often I get the question, ma'am, why can we just multiply by something? All right, we can't just multiply by something, but we can if we multiply the top and the bottom by the same thing, because then we're actually just multiplying by 1, but in a clever way. All right, in a way that is going to just manipulate the way that the fraction looks, but it's not actually going to change the value of the fractions. Okay, what I want you guys to do is to put brackets around the top and the bottom, please. Because essentially we're going to have to multiply that cos x by both terms in the numerator and then by both terms in the denominator. Yes.
Sorry, by multiplied by the bottom of the inner fraction.
So these smaller ones are the inner fractions. So in this case, they have the same denominator. So we don't actually have to find the LCD. We're just multiplying by the denominator. But if that was like a cos x and this one had a sin x, we would have to multiply by sin x cos x. Okay. Right, guys, now we're going to multiply cos x into the numerator, into this bracket. So what is sin x over cos x times cos x? Sin x. Already we've gotten rid of one of the inner fractions. Okay, that's why we times by that denominator so that it will cancel out the denominator. Plus sin x times cos x is just sin x cos x. You can put a dot there if you want, or you can just write them next to each other. Doesn't really matter. What do you guys notice already if we're looking at these two terms? Okay, the common factor of sin x, hey? That's what we're going to do next. Okay, at the denominator now, we're going to multiply cos x by both of those terms. So 1 times cos x is cos x plus 1 over cos x times cos x is 1. Now guys, isn't this much easier to work with than the way that it was written at first? All right. We still have a fraction, but we don't have fractions within the fraction. Okay, so this is a trick of getting rid of the inner fractions. If you just multiply by the LCD of those inner fractions, then it will cancel out those denominators. Okay, now remember, what are we trying to get to? We want to get to sin x. All right, so let's see what's going to happen. We already said that we have a common factor of sin x here. So let's take that out, sin x, bracket. Remember, when we take out a common factor, we divide each term by that. So what is sin x divided by sin x? 1 plus sin x cos x divided by sin x is just cos x over. Now, guys, at the bottom, we have cos x plus 1. But can I write that slightly differently so that it looks the same as my bracket? You don't have to, no, but I'm just going to. Cos x plus 1 is the same as 1 plus cos x, hey? Isn't it? And if you want to, you can put brackets around those two. But you also don't really have to. All right, that's just a preference there. Do we see we have the same thing at the top and the bottom? Let's cancel them out. And what am I left with? Sin x, which is what we had on the right hand side. Okay, so guys, that's what you have to do if you have like smaller fractions within your numerator or your denominator or both. Okay, and like I said already, I'll be with you now. If these two fractions had different denominators, all right, I said it already, but I'm going to say it again. So if this was sin x over cos x and that was 1 over sin x, then you would have to multiply by sin x cos x so that it will cancel out both of the denominators. All right, so that's why I'm saying the LCD of the inner fractions. In this case, the inner fractions have the same denominator, which is why we just multiplied by cos x. But if they had different ones, you need to multiply by something that will cancel out both of the denominators. Okay, so that's the LCD. Yes. It's up to you, really. Well, yeah, you can decide what you want to do first. But I'm inclined to just first get rid of the fractions so that it's a bit simpler to work with. But yeah, it's up to you. Okay, we're going to do another one now where we also have to multiply the top and the bottom by something, but it's a bit more difficult. It's not as obvious. So prove And again, it's a fraction, so I'm going to write it over 2 lines. 1 plus cos x over sine x equals to sine x over 1 minus cos x. Yep. So guys, like Jasper is saying there, we have identities for sine squared and cos squared and 1 minus sine squared and 1 minus cos squared, but we don't have any identities for just sine or just cos or just 1 minus cos or 1 plus cos. So this is a bit of a mess because we actually can't do anything, right? We can't change anything there into something else. Do we see? 1 plus cos x, I can't actually do anything. I can't change cos x into something. If it was cos squared x, yes, I could change it, but we don't have an identity for cos. We don't have an identity for sine. It has to be sine squared. Be with you now. Same thing here. We don't have an identity for 1 minus cos x. It has to be 1 minus cos squared x. All right, so we're a bit stuck here. There isn't actually anything we can do. Yes, Fayaz? You can't really square it because then you're multiplying the top and the bottom by different things. If you're thinking of squaring. But you are on the right track. We are going to do something to the top and the bottom. Yes, yes. The right-hand side just 1. So if it was sine squared and cos squared, yes, then it would be 1. All right, but because they're just sine and cos, they're actually not. Yes. So you are on the right track, but we're not finding the LCD of these two because remember when we're proving, we're only working on one side at a time. Okay, but you are correct. We're going to have to change this to sine squared. Yeah.
Are we allowed to times both sides go with like 2 to the minus 1? Is that a natural fraction? 1 minus 1. But you have minus sign.
See, it's a plus and a minus. So it's different things. James?
I was going to say just the
Mhm.
so it could be multiplied by 1 to the negative 1. That would be a fraction.
By 1 to the negative 1. So I think what you guys are trying to do is you're trying to change the fraction, but actually we have to multiply by something and the same thing at the bottom. So you're kind of on the right track. Sorry, just not quite there, Robin. You could if you wanted to, yeah, we could do that. So we could say 1 over sine x plus 1 over tan x then, yeah. I wonder if that would work. Yes, we could try that. Okay, I just want to show you something else, but that could be a possibility. You could split the fraction up because you have one denominator. Fayaz? You could use the right-hand side as well. We can do another one. I just want to think quickly, how can we change the left-hand side first? Well, we can talk about the right-hand side just now. Yes, Robert? Can we try that, guys? Let's think. If we decide to multiply the top and the bottom by the same thing, all right, remember, we have to do top and bottom by the same thing because that's what makes it equal to 1. Let's look at what we're trying to work towards. We're trying to change this into that. Now, my feeling is if I can change sine x to sine squared x, I'm just thinking ahead now, I can change sine squared to 1 minus cos squared x. And then I could possibly factorize that because it's a difference of 2 squares, right? In which case, one of my brackets will be this. So let's see. I'm going to write it down. And then you'll see how that works. And then we can talk about what we could do if we were working from the right-hand side instead. All right, so we have 1 plus, oh, sorry, I changed it now. 1 plus cos x, my bad. 1 plus cos x over sine x. And guys, in this case, also just kind of try something, all right? So maybe you think, okay, if I multiply it by cos x at the top and the bottom, that also might work, all right? We're going to multiply by sine x at the top and the bottom, but even multiplying by something like cos x, that also might give you something to work with. Okay, so here, and guys, in this case, I'm actually not going to multiply the sine x into the bracket. You could if you wanted to. You would get sine x plus sine x cos x. But I think just because we're not quite sure of what we're actually going to get here, let's just leave it like this for now. Right? We might want to multiply it out a bit later, but let's just see what's going to happen first. Okay, now we see that at least we can now change the denominator to something. All right, we've created a sine squared x because we have an identity for sine squared x. So sine squared x we can now actually change to 1 minus cos squared x. And guys, another reason for why it's a good idea to multiply by sine x at the top and the bottom, it's not only to change this to sine squared x, but it's also looking ahead to what we want at the top. We want to get to this. So we actually need a sine x in the numerator, which we don't have on the left. Okay, so in order to introduce that, why don't we just multiply by sine x? Okay, because we need a sine x there in the end. Now, guys, this is something that you might not have thought of before because we haven't used it in that way, but this is actually a difference of 2 squares, right? Does 1 have a square root? Yes, hey, the square root of 1 is 1, and cos squared x also has a square root. So this is actually a difference of 2 squares. All right, I'm just going to write that there. Difference of 2 squares. So we're going to factorize that, and then you're going to see that that is actually exactly what we need. When you factorize the difference of 2 squares, you're going to get 2 brackets, and you put the square roots of each of those terms in the bracket. So the square root of 1 is 1. You're going to put a plus. The square root of cos squared x is cos x. Right, then your second bracket has the same 2 terms, but instead of a plus between them, you're going to have a minus. All right, and there we have it, guys. We have 1 plus cos x at the top, 1 plus cos x at the bottom. We can cancel them out. What am I left with? Sin x over 1 minus cos x. Which is the right hand side. Now, guys, if you wanted to start from the right hand side and change it to the left hand side, if we're looking at this and we're again thinking, what can I multiply the top and the bottom by so that it gets me to this? All right. Now here, do you guys remember when we rationalized denominators, when we did surds? Right, when we wanted to change the denominator, when we had a surd in the denominator and we wanted to cancel it out, and when we had more than one term, do you remember that we multiplied by the conjugate of the denominator? Does that word sound familiar? Which is the same 2 terms, just with a different sign in between them. So that is what we'll have to do here. All right, so if you have 2 terms in your denominator, I'm going to write that here. 2 terms in denominator. Then we're going to multiply the top and bottom by the conjugate of the denominator. So we are going to do it. I just need to do it on a new page. So I'll give you a chance to copy that down. Guys, you can choose to work from the right. All right, there's nothing wrong with that. So if you see that, oh, I have two terms, and you remember, let's multiply by the conjugate, that would also work. Okay, on the next page, I'm just going to rewrite this. I'm going to write RHS equals, and then we're going to work with this. Okay, let me just read that. Make sure that you've copied that down, please, that little note. I'm just going to rewrite the question. If you have space underneath, you don't have to rewrite the question. I just want it on my page. Sure, this wind. Okay, so we're doing this, guys, but now we're working from the right. Can we write this down, please? Now, guys, the conjugate of 1 minus cos x is 1 plus cos x. All right, so the same two terms, you literally just change the sign in between them. So we're going to multiply by 1 plus cos x at the top, and we're going to multiply by 1 plus cos x at the bottom. So that is going to give me at the top sine x times 1 plus cos x over. Now, if I have these two, I need to multiply the two denominators together. So it's basically, I'm going to have to FOIL them out, right? Because it's a binomial multiplied by a binomial. Remember, if you multiply multiple terms by something, you have to multiply all of those terms by both of the terms now in that conjugate. Right, so let's FOIL them out, guys. What's 1 times 1? 1. Now, if we do the outers, we're going to get 1 times cos x, which is cos x. The inners is going to be negative cos x, right? And then we're going to do our last terms, which is negative cos x times positive cos x. So that's going to give us negative cos x squared. Okay, so I'm just going to write that down. My spacing is a bit off now, but it's fine. So that's what you get when you multiply the denominator, which was 2 terms, by the conjugate, which is also 2 terms. Okay, so because it's 2 terms times 2 terms, you have to FOIL them out. Now, guys, so we see that the cos x and the minus cos x are going to cancel each other out, all right? Because cos x minus cos x is just 0. So, in fact, I have 1 minus cos squared x in my denominator, which is sine squared x. So at the top, I'm leaving it as it is. And guys, why am I not multiplying this out now? Let's look at what I'm working towards. I want that 1 plus cos x on its own in the numerator. Remember, we're going from this side now to this side. So if I multiply this out, I'm going to have to factorize it again later on. Okay, because I want that 1 plus cos x on its own. So that is now over sine squared x, because we have 1 minus cos squared x, which is sine squared x. And now, guys, I can cancel the sine x that I have in my numerator with one of the sine x's that I have in my denominator. I have sine squared x, which is the same as sine x times sine x, right? So you're canceling the one at the top with one of the sine x's at the bottom, and you are left with 1 plus cos x over sine x, which is what we have on the left hand side. Yes.
So now, when it comes to this, which one would you recommend? It's based on the question.
It really depends on you. It depends on what you see first.
Okay.
So for these questions, obviously now, David, for these questions, guys, I think it's better if you see that you can do something. Do it instead of sitting there and thinking, oh, isn't there maybe a better way or a quicker way? Or, you know, that's almost going to take more time trying to find a quicker way than if you were just to do what you notice first. David?
My other question method for
Okay, I'll be with you now. Let me just ask James. Yes? Quicker. It's literally, it's the same number of steps. Yeah, it's the same number of steps, I think. So it just depends. Maybe you see, okay, I have 2 terms here. I must multiply by the conjugate. Maybe you notice that first. Or maybe you look at this and you're like, oh, I need a sine x, so let's multiply by sine x over sine x. All right, it's literally what you see first. Okay. David, yes, what did you do?
put them and then I just one equals.
So here,
plus the next level.
the problem here is just that you can only do this if it was cos squared x.
Yes.
How did you get? So yeah, so these identities that you use, they're only for squared, not for without the square.
Square.
Yeah, so only if it's
Oh,
squared. Okay. All right, guys, I'm going to give you some of these to practice for Monday. So exercise 5, which is page 144. It's the same exercise that you had to do for today, but I want you to do numbers 8 and 14, and then exercise 6. Exercise 6 are these more difficult ones. On the next page, I want you to do numbers 1 and 3. I just want to take a look at these quickly. 8, okay, and 14. There's 14. 26, 1. And 3. Yes. All right, those are the ones I wanted to do for Monday. Guys, on Monday, we're moving on to the next topic again. All right, so you need to make sure that you are practicing these. There are loads of them in the textbook. So if you need more practice, you can work through them. All right, and just ask me if you get stuck. But there are lots. Okay? No, just with proving identities. No, definitely not. Guys, on that note, your second test, I know you guys are stressing about your first test mark because apparently the other class averages are not great. So I will mark them over this weekend, I promise. Sorry, it's just, yeah, it's been hectic these past few days. Your second test is not going to be a test in the traditional sense where it's 50 marks, you come in and you write the test. We're going to give you, and I think Ms. Tucker is going to post it today, a kind of home assignment thing. Which is grade 10 revision. So Trig, grade 10 revision, it's an exercise, 30 marks. You're going to take it home, you get a week to hand it in. So that is due next week, Friday. Write it down, please. Write it down, write it down. Plus, no.
What did you say?
So that is due on the 17th. It's today the 10th, right? Yes, so that is due on the 17th. In this lesson, you're going to hand that in. No, so we're hoping that these marks will. And then you are going to, on the 20th, which is the Monday after that, you're going to write a 20-mark mini test. It will probably be like 25 minutes on the new grade 11 Trig. All right. So 30 marks, take home, grade 10 revision. You are going to get that on Google Classroom. Guys, she's going to post it, but if any of you need me to print it, just tell me on Monday and or email me and I'll make a copy for you. But you don't really need, it's going to be on Classroom. And then the class test, it is an in-class test, but it will obviously count 20 marks. It's going to be on these types of questions, proving identities and reduction formula, which is what we're starting on Monday. All right, so that is the following Monday, so the 20th, 20 marks. We're then going to combine the 30 and the 20 marks, and that will be your second test mark out of 50. Okay. Yes, a week from now, you're handing in the grade 10 stuff, and then after that weekend, you're doing the grade 11 level test. You know?
So just proving identities, so not the stuff for the time.
Yeah, probably that stuff as well. Yeah, so it's that, proving identities, and then reduction formula, which we're starting on Monday. Yes, Haley? Yeah, so it's 50-50, yes. So guys, we're pushing with Trig now. Hey, you need to make sure that you are on track with this stuff. Please, you're practicing every day. All right? Yes? The what? The class diagram stuff. Yes, probably. Yeah. I haven't seen it, but it's, yeah, that will be under the topics. No, it's functions. All right, guys, work on these, please. Let's go. What is that book? Oh, this is the wrong one.
The one that was like.
Okay, exercise 5. Let me just take it 8 and 14. So 8 and 14. Okay, guys, there are the first two. I'm just going to zoom in a bit. Get going, please. Let's stop talking. Let's focus.